The activated sludge treatment process plays host to countless numbers of microorganisms. These organisms, which are an intricate part of the activated sludge process, are sometimes more affectionately referred to as bugs. The microorganisms, or bugs, which are commonly used to characterize activated sludge, are protozoans, rotifers, and nematodes. Of the protozoans, there are three groups that are significant in the activated sludge process. They are amoebas, flagellates, and ciliates. Amoebas, the most primitive of the protozoans, are single-celled and ingest food by absorption. Mobility is attained by the movement of protoplasm within their bodies. Amoebas are usually predominant in the early startup stages of the activated sludge process, or when the process is recovering from an upset. Flagellates are round or egg-shaped in nature and are propelled by a whip-like tail called the flagella. They move either in a straight path or a corkscrew pattern. Flagellate predominance may be associated with light dispersed floc and a high F to M ratio. As the activated sludge ages, the flagellates' population decreases as they are unable to compete for food with the larger organisms such as the ciliates. The third group of protozoans, ciliates, are characterized by little hair-like projections called cilia. The cilia cover all or part of their body surface. They're commonly found in two forms, free-swimming and stalked. Free-swimming ciliates are round or oblong and move in a smooth gliding fashion. They're commonly found when there's an abundance of bacteria. A predominance of free-swimming ciliates usually indicates good treatment. Stalk ciliates look like branches with bell-shaped ends and are usually found attached to clumps of activated sludge floc. They do not swim, but can be seen coiling and uncoiling like springs as they feed on smaller organisms. Stalk ciliates are usually found when free-swimming ciliates can no longer successfully compete for the food supply. These ciliates are also an indication of stable and efficient treatment. Along with the protozoans, rotifers and nematodes can also be found in activated sludge. Rotifers are tube-shaped with a forked tail and two rotating wheels of cilia on their head, while nematodes are worm-shaped. Rotifers and nematodes are usually much larger than protozoa and are indicators of an older sludge. Overall sludge quality and the ultimate performance of a sewage treatment plant can be related to the number and type of the microorganisms found in the facility's activated sludge. For example, a predominance of amoebas and flagellates with some ciliates can indicate a young sludge characterized by poor settling. A predominance of ciliates with a few rotifers, flagellates, and amoebas indicate a good quality sludge characterized by good settling and high treatment efficiency. On the other hand, a predominance of rotifers, nematodes, and ciliates with few or no flagellates and amoebas indicates an older sludge with rapid settling characteristics. The relationship between microorganisms and sludge quality can best be pictured by the use of a relative predominance bar graph. Another factor which also plays an important role in a sewage treatment plant's performance is filamentous bacteria. The amount and type of this bacteria in a facility's activated sludge determines the type of floc structure which will develop. A balance of filaments and microorganisms will yield a good settling sludge and a clear effluent. A moderate number of filaments serve as a backbone for good floc structure. However, too many filaments can lead to poor sludge compaction and sludge bulking. There are two types of floc structures that form when sludge bulking occurs. The first is interfloc bridging, when filaments extend from floc surface and holds the floc apart. The second is open floc, where the filaments grow mostly within the floc and the floc grows around the attached filaments. If a facility has an overabundance of filamentous bacteria, the filaments should be identified and the proper corrective action taken. This overabundance of bacteria in an activated sludge system can be very detrimental to process performance. Through the regular monitoring and identification of microorganisms in an activated sludge system, the operator can often prevent serious operational problems. A daily microscopic evaluation can be a very useful tool in the routine operation of a wastewater treatment facility. It could also prove to be a new and enjoyable experience for the wastewater treatment plant operator. The following is a pictorial reference library of common microorganisms associated with an activated sludge treatment process.